Am I audible? Please, anyone confirm? Okay, thank you. Uh, Let me start the record. Is my screen visible? Okay, just give me 2-3 minutes. Let the others join. Then we will get started. So this is the last problem solving session. I hope you all have enjoyed it. Uh, Today I will discuss about wicket content, basically about recovery and query optimization. So uh, we will just solve the previous year questions and try to grasp the concept. It is very easy concept. Wherever you will get some pass, you have to roll back. We have to do some recovery and do redo. So just wait for 2-3 more minutes. Later just join. Otherwise I will get started. Uh, Sorry. So we will do some questions upon based upon the checkpointing and recovery. Then some seek time and block transfer based questions for file scan, and one or two theoretical questions. Those are very obvious for the sake of perfection. And then some equivalent relation and the cost related questions. Okay, so it's 6-3. Uh, let's get started. So in the first question, they have provided 4 transaction log records. Sorry for bad voice. So just read the question. Assume an immediate database modification scheme. Consider the following log records for these 4 transactions from T0 to T3. If there is a crash just after 9, so we have a crash after this transaction statement, and the recovery of system is successfully completed. The correct action for the above scenario, what will happen? So whenever recovery happens, what happens? The variable or the means operation what is performed on some transaction gets reverted. Okay, so if any operation or any change is performed on this x variable or x data, then it gets reverted. Uh, and if there is a checkpoint, then we do accordingly. If there is not a checkpoint, if it is committed, then we do accordingly. So based upon that, we have to provide some uh, correct statement. What is the correct? Okay. So first is telling after a recovery completion, value of Z will be 500. Is it correct? Just be little interactive. There is a chat box. You can write the answer because I think this module is very simple. So if you go through lecture, there are 4 lectures about the recovery and query optimization, and those are very obvious kind of questions. So I want everyone to just attempt these questions and write their answers on this chat box. Okay. So is one correct? Obviously not. Okay, A is wrong. Why? Because there is a old value of 2000. If it will revert to 2000. Okay, so it is wrong. Second one, after recovery completion, X will be 500. Is it correct? Just see, is there any commit, is there any checkpoint before it? So there is commit of T0. T0 is having this X. So X was updated from 1000 to 500, and before the crash it was committed, means it is on physical record. So it is actually correct one. Next, the third one, just see, the redo list contains transaction T0 and undo list contains T1, T2, T3. So just you can do it manually after based upon seeing these things, or you can just create a timeline kind of thing. You just write the write it like checkpoint. There is a checkpoint one. There is checkpoint. Okay, and there is a failure. Okay, can you show in more detail? For details, you can prefer these lecture slides. It is very clear. Uh, I cannot present lecture slides again and again. Uh, okay, just understand the concept. Whenever a transaction is going through checkpoint, if any transaction is done before that checkpoint, then we should not care it. We think it as that don't care condition. If there is anything happened uh, in transaction and in between there is a checkpoint, then the means value gets stored. But when a transaction is means in run till failure, then we have to undo it. Okay, means the transaction is not yet completed, we have to overall recover the process. Okay, so just create a timeline like, okay, before this checkpoint, uh, there is T0 which was actually completed and T1 was started. So T0 was actually, if we consider it as initial line, so T0 was completed and then T1 was started. T1 wasn't completed, but there was a checkpoint. Okay, so what happened? Checkpoint was done on T0, T1. Then there was T2 started after this checkpoint, and it wasn't committed. Okay, so after checkpointing, T0 was committed. There was commit statement, but T2 was on run. Okay, then T1 was also on run. T1 is having some operations. If you don't mind, then I need to cover from you. Actually, I am still covering the syllabus. Uh, need to revise one last revision class next week. I know that it will be a detailed session, but you know the link will remain there. So if you can come next week anytime, whichever suits, send it out. Just one more session before exam. Actually, we are not able to. I'm personally not able to do so. Next week there is a Diwali break, you know, and we are actually our, like our work was to just cover up to 8 weeks. So each PMRF fellow is appointed for 8 week course. I don't have any problem coming any day, uh, but we have also other research work. So that's why if you can write. Uh, there is my Gmail. Uh, okay, I will try, but it's not fully possible. But because I cannot come officially. Officially, the the session was till today. So unofficially, I can try, but I cannot promise. Okay. So if NPTEL will tell us for this, we will be grateful. We will, yeah. So Before course starting of the course, we are provided these timings, and based upon that, we are getting lectures. So it is pre-scheduled, so we have to just perform our duty. And so, just I will try, but I will not promise. Okay. Okay. So coming to the question again, what I was telling, we can create some kind of timeline, kind of this diagram. We can start the transaction from initial stage. Let's say it is initial stage. Okay. In this initial stage, what we can do, uh, uh, so let's start over first. Okay. Uh, got corrupted. Okay. So let me complete this one first. So for the third and fourth line, third and C and D, I am going to create this kind of timeline. Okay. Just consider it is an initial state. It is a checkpoint, and this is the failure state. So what happened? After 9 there was a crash. Okay, till then we have to see where the transactions got started and where it got finished. Okay, so if we see this T0 got started and checkpointed at this checkpoint. Okay, so T0 got started, and at checkpoint it has certain values, certain amount of data which this it is having in process. Then T1 got started also, not from initial stage, but it was also in run after this, uh, we can say checkpoint. Okay, so it will go after checkpoint. Okay, it is T0, it is T1. After certain point, after just after checkpoint, T2 got started. Okay, just consider this is T2. Then T1 got committed. So T1 is actually uh, T1 has done its work. Okay, so T1 after a checkpoint, it is having commit state. Then there is nothing commit. There was T3 got started, and till the end, all these three T1, T2, and T3 all were in running process. All were actually the running process, running transactions. Okay, so what we can infer, the processes which are having checkpointed was T0, T1, and we have to see for redo and undo. Just a second. Excuse me. Just a second. Okay. So till this uh, the processes which were running, the transactions which were in action till the failure, they will just get that undo list, and the transactions which were done before that failure will actually revise their schedule, so that will be in redo list. Okay, so T0 was done before it, so it will obviously in redo list. Then if we see all these three, T1, T2, T3, all were in action, so these were not committed. There was no commit statement in this proper log record, so we take all these three to the undo list. Just see the options. C is telling the same, D is telling the another one. Okay, so it is wrong. So answer will be B and okay. Now coming to this question, this is quite similar. Just create that kind of diagram. Okay, so what we have to do, we have to create just initial stage. Is there any checkpoint? Yes, there is one checkpoint here. Then there is some crash after 12th. Okay, after this one. So there was crash. So from initial stage there was T0. Sorry, T0 was there. Then after some time T1 got started. Then there was checkpoint. Checkpoint was on T0. Okay, checkpoint was on T0. Then after checkpoint T2 got started. Then T3 also got started, but before that T0 was on commit list. Then before checkpoint T1 was on commit. It was done. Then after some time before failure T2 got commit. Then T3 was in action. Okay, now just see the options and comment the right option according to you. So if we just infer from this diagram, so the processes which were actually completed before any checkpoint, we can just ignore them. Okay, so we should not take action on them. Okay, so T1 is such kind of, yeah, got it, nice. So T1 is such kind of transaction, so T1 will have no action. Now coming to next one, there are two uh, actually transactions which are actually which were in action after checkpoint but got committed before crash. So T0 and T2. So T0 and T2, what we should do, we should redo it. Okay, because these were done till now. Then there was T3 which was in action. What we have to do, we have to undo it. Okay, now comment. There are uh, there are four options. I think the D1, yes. Okay, D is the correct one, which is telling the same which we have inferred. Okay, now consider this question.
I have a question
Yeah, yeah,
regarding precedence graph.
yeah, yeah.
In the question, like when we consider you create the graph, do we create a edge when reading is happening after the write? I mean, in
Read is after write. Read is
yeah,
after write. Yes. Where there will be conflicting pair. We just see the conflicting pairs. Okay. So if there is a conflicting pair like WW, RW or WR on same variable. Okay. If WA, then there should be WA or RA, or means if there is RA, there should be WA. Okay.
yeah.
If there is any non-conflicting pair, then we should not care it. Okay. We can
Actually,
swap them. Okay.
in the last assignment, there was a question, and when reading is happening after write, there is there is no edge between in the precedence graph in the solution. So I just want to clarify this. I mean,
Okay, so
if
this
it's,
week question.
like it,
Anjali, please mute your mic.
if you can check the question last week assignment question.
We are actually not told to means cover the means this running session assignment. So if there is edge, if you are sure there is not conflicting pair, there will be no edge. Okay. So we have to just look after this. If there is WA, we have to look for WA or or RA. Okay. If there is so,
In the
we should
solution,
have. Okay.
in the solution provided, it was said that like in the graph, when read is happening after write, there is no edge in the graph. When they consider, because write is happening after the sorry, read is happening after the write on that
Read is
aspect.
happening after write.
Yeah,
Read is happening
and
after
there
write.
is edge if read is happening before write, then there is the edge. And
Uh, no, no, no. We have to actually just one thing more. If there is a
you
timeline,
can, yeah,
if
you can
we
have a graph like in the second last element there is a write, and in the last element there is a read. So will there an edge in
if
that case?
if if there is consider if there is WR
Yeah,
and WA and RA,
yeah.
then there will be edge. Okay, but if there is RA, there will be no edge. If there is WA,
So
this is happened. Okay,
consider the first case. Consider the first case when the first line is second last line and the RA is the last in the last line. Will there be an edge or not? Because in the
RA
solution
in
provided,
the last line.
yeah.
Then from RA there will be no edge. Okay, if there is T2, if there is T1, then from T2 to T1 there will be no edge because till here it is done. Now you have to see for this. When we were executing it, we have to consider this one. But if
Yeah,
we are
yeah, yeah,
executing this,
that's
then
certain.
till this it is done.
Okay, so there should not be any edge from RA to WA. There
No,
will be
if
edge
it is
from
happening
WA.
after it, then there will be no edge.
Yeah, thank you. Thank
Okay.
you.
Yeah.
Yeah.
So this is very simple question. If you went through just yeah, Avinuti, Srinidhi M Avinuti. Yes. Is there any question? Okay, if there is any question, you don't want to interrupt, you just write on chat. I will definitely consider it. So, there is a simple question uh, regarding this block, and there is a key attribute. We have to perform linear search file scan. So, there is the number of block containing record, that is B, is having 200. Okay, then TS, the time for one seek, that is 4 milliseconds. Then there is this time to transfer, that is TB, that is 4.0.4 millisecond. Now there is provided that is key attribute. So whenever there is key attribute, what we do, we just perform the cost as BR by 2 plus 1 seek. Just apply this formula and comment the answer. Okay, I am doing it for you. So BR is this. Okay, BR by 2 plus there is 1 seek, sorry, into multiply by this time, time means TB. So multiply by 4 millisecond plus there is 0.4 millisecond. Okay. Oh, sorry. I think I have written it wrongly. Sorry. 200 by 2 multiplied by zero point 0.4 plus there is seek time TS, that is 4. Now what will be the answer? 100, that will be 40 plus 4, that is 44. Okay, answer is D. Is there any doubt? That is very simple, simplest one. Okay, now coming to this one. Okay, there are multiple checkpoints. There is a system failure. We have to complete, we have to comment on it. So consider the following state of transactions and the statement below. We have to identify correct group of statement. Okay, so just comment. T1, T2, T3 can be ignored. Is it so? Before before the last checkpoint, we have to consider this last checkpoint. Okay, before it we can consider anything. Okay, so before last checkpoint, those transactions which were done, we can tell them we do not need. Okay, then the transactions which were completed after this checkpoint, just consider them for redo list and rest for undo list. Okay, so comment, now comment it. T1, T1 is completed. T1 got completed actually before checkpoint 2. Okay, T2 got completed checkpoint 2. Okay, T3 got completed before checkpoint 2. T4, T4 wasn't completed. It was, but it committed before the failure, and T5 was there when the failure happened. When the failure happened, so from first statement, T1, T2, T3 can be ignored. Yes, T1, T2, T3, those all three were actually completed. So this is the right one. Then only T1 can be ignored. No, from first statement only you can consider it. Then T2, T3, T5 need to be redone. Why? T2, T5 was actually in progress. So what we can comment, it should be undone. So no, only T4 needs to be redone. So T4 was the only one which was in progress, and it was completed just before failure. So it will be redone. Only T5 needs to be undone. Yes. Okay. So answer will be 1, 4, 5. Is there any option? Yeah. C. Okay. So from fifth, is this C? So any comment? Okay. Yeah. Good. Neetu and Karthik. Yeah. Correct. Fine. So now we should go for next one. It is also a simple example. Simple question. Let us consider the following statistics for two relations, pizza and sold by. So there is NP, there is NP that is 2000, then there is VP that is 4000, there is NS that is 500, there is BS, there is 100. So we have a natural join this and assume pizza at the outer relation. So it is the outer one. Now what we have to do, just a simple thing, identify the required number of block transfers in worst case using nested loop join. Okay, there is a simple equation. We have NP and this for worst case number of block transfers. What we have to do, just multiply these two, NP by BS, and then add this one. Okay, that is the 2000 plus 400. What we got? 200400. Okay, answer B. There is another thing. There is a seek. Just a second. Just a second. हेलो. हाँ भैया बताइए. नहीं, मैं आ गया हूँ. सुरभि इस समय हॉस्पिटल गई है. मेरा एक्चुअली लेक्चर था तो मैं लेक्चर लेकर के फिर निकलूंगा. भैया सुरभि सुरभि का नंबर मैंने भेजा है, उस पर कॉल कर लीजिए. बता देंगे। हाँ ठीक। Sorry, there is a medical emergency. Okay, so there is another thing like seek. So can anyone write the value we will get as a seek, number of seek? Uh, so for seek, what we do, we just write this n pizza plus n sold by. Okay, 2000 plus 500. Okay. Just go through the slides. There are four things. If there is one relation as outer one, there is another relation as outer one. So for each the case, there are multiple things. Okay. So like this, you have to solve these questions. Okay. Now this is actually about the equivalent trees. So if we see, we have to first comment on whether these are equivalent or not. So till here, this is same. Okay. Now there is flight file same. Now from here, what we have to see, these two are actually um, same or not, equivalent or not. So if we select a name from pilot ID, then we have to join on pilot ID. We have to select this. Finally, we have to go for the color. So if we here apply projection operation, there will be no not any kind of essence of this. So we will just end up in color. So this is actually the any kind of redundant statement you can say. So just go through one by one. So actually the effect of this will be actually negligible. So these two uh, trees are actually equivalent. If there is some confusion, just take some values and perform these operations, you will get the right idea. These two are actually now equivalent. So just identify the correct statement. Two query trees are equivalent as identical operations irrespective of their positions are used in both the trees. Two query trees are not equivalent, so it is wrong. The two query trees are equivalent and the query tree of figure 1 will lead to more efficient query processing. Yes, because there is one statement which has no use but it is taking some cost. Okay, so C is one correct option. What about D? Figure 2 will lead, so it is wrong. Okay, um, just comment on first one. Uh, both are equivalent as identical operations. So there are no identical operations. There is one different operation and irrespective of their positions. Okay, so it is also wrong. So answer is C actually. 7C. Now just do this. This is actually based on this tree only if you see. So there are four relation algebra queries are given below Q1 to Q4. We have to perform correct. We have to search for correct equivalent equations. Okay, we if we see the options, we have to just search for equivalency of Q1, Q2, and Q3, Q4. Okay, so just see Q1, Q2, and Q3, Q4. What is happening? Uh, so from first to, if we perform this operation, select operation inside select operation, so this condition gets actually intersection. Okay, so what we say, uh, select from pilots files where fno equal to 1001, and then we will apply select on this also. Okay, select on this where age is greater or equal to 30. Okay, if we take it as we have to just satisfy these two conditions. Okay, so if we see the if you will see the equivalent relations slide, there is some kind of nomenclature, or what I say, uh, there are mnemonics for it, and there is a proof, not proof, then there is a formula that if we have two conditions, we have to satisfy these two, so there will be AND operation actually. Okay, so what we are searching for, we are searching for this natural join table where fno is equal to 1001 and the age is greater or equal to 30. So it is clearly seen in this, there is written as the AND statement. Okay, so q1 and q2 are actually equivalent, so a is correct. Okay, b will be definitely incorrect. Now coming to the next one, what it is telling, we have to select p name. Okay, in both there is some selection operation, in between we have to just consider this one. What we are getting, we will select pilot id and p name from here, and then we will again filter it the p name. So ultimately if we perform projection operation, then the equivalency says that if there is some projection uh, outside the projection, we consider the last one only, that will result in the same answer. So these two will also be in same, because if in very naive idea, if you see what we will get from this table, until this what we will get some table of having pilot id and p name, and from there what we have to select, we have to project this only p name, and if we see this one, we will only get p name. Okay, p name. So ultimately what we will get, we will get the same result. Okay, so q3 and q4 both will also be actually equivalent, so d will also be wrong. So what is the answer? A and okay. Sorry. Now just see them and just uh, identify the incorrect statement from here. 9p. I am giving you 2 minutes time. Just I am drinking some water. You just comment what is the incorrect one. This is basically on the PPT. If you will just go through the PPT, if you don't have PPT, just download it from Swayam website, and just go through these keywords. You will get the answer. So actually these are the definitions. So what we say, the immediate modification scheme allows updates of an uncommitted transaction to be made to the buffer or the disk itself before transaction commit. It is actually correct option. Okay, just go through the slide. It is written over there. Uh, then they have written the same for deferred modification, which is not correct. Okay, because it's little different. Then physical blocks are those blocks residing on the disk. Is it incorrect? No. Yes, it is correct. Then system buffer blocks are those blocks reside temporarily in the main memory. Okay, so what we got? The answer is B. B is the incorrect statement. Okay, so this is one thing. Now coming to this one. So what it is telling, to consider the relational algebra expression below, we have some join statement on B minus C where A, B, C are relational algebra expressions. Identify the correct equivalent relational algebra expression of the above relational algebra expression. So if we just go through equivalency, uh, the operation before this bracket actually gets distributed. So by that it is actually the correct one. Okay, B is the correct one. So there is nothing like any other option correct. If there is any confusion, you just second question was not there, that was lengthy, so I had to cover all these things. I haven't taken that. After first, I have taken the third one. Okay. Second one was actually for that equivalent kind of recovery schedule. So I will next I will discuss some slides. So from first there was B and C. Okay. From second I skipped that. That is simple one, but we have to, that will be time consuming. I think. So the third one, the option is D. Yes. For fourth, option is D. Just confirm it. Five, option is C. Six, it is actually D. Okay. Six B. Seven, there is C. Eighth, there is A and C. Okay. From ninth it is B, and from 10 it is B. Ninth it is B. We have to uh, identify the incorrect statement. Okay. Not A C D, it is B. Okay. So that is all for problem solving part. Let's discuss some lecture slides and then we will get over. Okay. Yeah, thank you for that. So I am just unsharing it for a while. I will reshare my screen. Just a second. Let me share my screen. Yeah. Now, so this is actually the last week content. There was something about failure classification, then there was storage structure, then there was some recovery or atomicity, then log based recovery. So just go through this point. I'm just revising it from last 10 minutes. So we know the transactions would have acid properties, atomicity that tells all or nothing. If the transaction will happen, it should go through all the steps. Then there is consistency, means there should, if there is any integrity point, we have to preserve it. Then there is isolation, so we have to execute as means, one process, one transaction is running alone. Then there is durability, means results are not lost by failure, that should be consumed anywhere. Okay, then there was something that concurrency control guarantees this isolation, contributes to this consistency, then application program guarantees this consistency, then recovery subsystems guarantees A and D and contributes to C. Okay, so there were some kind of errors they have covered. So errors are basically a kind of, if there is a transaction failure, then there will be two kind of transaction failures. First is logical one, means there is internal error, transaction was not able to complete. Then there is some system error, means if there is deadlock or if means system will have to actively terminate it. Then there is system crash, means if there is a power failure or hardware software failure, then the system gets crashed. That is about it. And then there is fail stop assumption, means if non there is non-volatile storage, we should consider that if there is any non-volatile kind of storage, then the things are permanently stored there, that should not get affected. Then there is a disk failure. We use the checksums there. Just a second. Okay. Now the next there is recovery algorithm, means we have to just take that example of what is taught in the slides in the lectures, that we have to subtract 50 from A and add to B. We have to just recover it, means we have to just recover from the failure. So these are the storages they have told. If there is volatile, it will not survive. It, if that is not non-volatile, we just consider that it may survive. It is not ideal. Okay, so we just consider a mythical form of storage, that is stable storage. There, that is, if there is a there are multiple copies of some storage, then if there is some crash in one, then there will be update, it can update from the next one. Okay, so this was something that was taught. If there is a stable storage, then and there is a buffer, the first thing there, if there is a read write, that will be on buffer. Then the stable storage, secondary storage, takes the all the things from the database. Okay, these are all about the data access. So the one thing we have to remind in our mind, we have to remember, that is if there is some transaction, some kind of operation between this memory to disk, that will be input and output. If there is something within that memory, so in buffer to its private area, that will be read and write. Okay, then there are shadow paging, log based recovery, this kind of questions we have done today. Okay, so I'm leaving it. In next module there was concurrency control, simple, that same redo undo phases. So these were some examples. Now next is the query processing. So in query processing, this is not the actual diagram, there is some problem in this PPT. So these are actually the uh, steps from which the query gets processed and provides the output. Then there is a query optimization, where we just take some queries and we try to get the optimized equivalent, which takes the lesser cost. Okay. Then there is some cost based questions we have already done. There is query cost, selection operations. These are different formulas, we have to just apply them and we will get results. Then there is sorting. If there is some initial relation, we can just create runs. Then we have to merge. We have to just sort the chunks and we have to merge them. And after certain passes of merge, we get the sorted out. Okay. Then there is uh, that is the question about like we have done for pitch and that sold by. There is a student and takes. Same thing they have done. Just see, there are number of seeks, there are number of block transfer. If there is different kind of relations, you can see this. Okay, there is block nested loop. Then there are different operations you can see, and these are about the equivalent expressions. Okay, so we have done one such question. These are some rules. Just see what we have applied. If there is some equation like this, there is true selection on certain operation, certain relation, then we can just apply and on these two. Okay, and we can also uh, means revert means interchange between these two. And if there is a projection operation one after one nested one, then the outermost gets the priority, and not priority, outermost operation is the final result what we get. Okay, so please I should not tell today because we not time, it's last class. Okay, so equivalence relations, these are like, just see, there are some rules. Then there is some course recap. So in course recap, I think everything is reminded. So there was some relational database based on the relational model of data. There was some key, there was some data, there was some foreign key. So just summarizing all the things. So after that there was DDL, DML. So database definition language, data definition language was for defining the database. Then there was DML for manipulating the database. There are certain servers, there are certain frameworks which are used for executing SQL queries. So you can go through those, and then there are some common RDBMS systems. So you can go through those also. Then there is Oracle. They have provided the case study of Oracle. This Sybase, DB2. These are some certain. Now, currently there is no SQL kind of databases are more popular. So you can go through those also. There is MongoDB, and another one. That is this is object-oriented DBMS. Then there are parameters. So we should have OS support, we should have fundamental features, limits, table views, and all. So then there is the comparative study, there is basic features. So uh, just I'm looking into this Oracle one. So it should support this acid properties on transaction. It should implicitly commit for DDL. It should have referential integrity, means it can refer, means within relation there should be within relation there should be some join. We can perform row level locking for fine grained locking. Okay, then concurrency control for better execution. Okay, then the limits you can see. So every time you just select the database for your use, you just go through those the specifications, and according to your need you can use it. Then these are comparative studies. Okay, so there are two things, static and dynamic. So that is very simplest one. If there is static, we have to uh, store the static data. If there is dynamic, we can dynamically change the data also. Okay, then data types, varchar is there, varchar there, but they haven't written name. Okay, like that. Then partitioning, There was hash. From here you can see the use of hash is there. So in hashing, you all know what we do. We just take some value, we perform some hash function over there, and we store the final value. So it gets actually encrypted. uh, for access control, I can say that based upon the security we want, we can check like uh, native network encryption is there, separation of duties is there. We can means no authorized person for certain tasks should get access to any other uh, data. Means if there is a student and the faculty, the student should not get any writing kind of uh, permission on the grade sheets. Okay, they should have view permission. So likewise, okay. So there are non relational databases. Then there is big data. Okay, there was only three earlier: volume, variety, and veracity. But now there is five V's. So volume, for big data, the volume should be where we should store the data. Then variety means type and nature of data, which kind of data we are actually accessing. Then there is velocity, how is in which speed the data is generated, like in Facebook or Twitter. uh, certain If certain tweet gets emerged, then it gets millions and millions of retweets. So where we should how we should store that, it comes under big data. Then there is a variability, means there should be no inconsistency. Then there is veracity. So data quality of captured data can vary greatly. Okay. Now there is non-relational databases which we actually use to sorry we actually use to this try to get more and more data storage. So there is MongoDB, DocumentDB, Cassandra, and there are multiple ones. Okay, so these are some theoretical things you can see. Um, so they have also provided the profile mapping. So this is actually the final thing. What I will also say. Okay, is there any comment? Yes, please. Ranjay Chintala. Okay, so for system failure, will transaction be redone for undo too? If there is system failure, it is actually based on the what we can say. If there is a system failure and your buffer and the physical depends upon your physical storage gets affected or not. So if there is a checkpointing, like I have earlier told, if there is a checkpoint, then till checkpoint the values will get stored. If there is a commit before failure, that will be committed to the your database. So if that is committed before that the checkpoint, then we have to take no actions. If that is committed after checkpoint before failure, then we have to redo. Otherwise, we have to undo. Okay, but if there is a overall system failure, we don't have any kind of means timeline or any kind of log, then we have to certainly restart it. Means we have to go from initial state. Redone for undo, that is not yet possible, I think. Okay, any other person, if anyone wants to comment on it, it is open for all discussion. Okay, so that is some Final words from my side also. You have to read these things and practice coding these queries, practice databases design, and the best thing you can do is just apply these things. Okay, and you can mail them and mail me also if there is certain need I can provide. Okay, so my mail is I think there in the portal. Okay, so I think that's all from my side. Thank you very much for attending it. I hope I tried my best to provide you uh, some certain kind of good questions, how to interact the questions, how to do it, and hope we will from next course if I get um, chance to again go for some certain courses. So from my side, it is done. Very thank you for attending. I think there are some students I know their names and they were actively participating. I will not tell their names, but that is good gesture towards me. So thank you everyone. Let's close the meeting. I hope you have enjoyed the lectures and got some uh, great knowledge. Not great, then just kind of knowledge which you can uh, use for solving the problem in case of databases. So thank you from Saurabh Sharma, PMRF fellow from IIT Patna. Thanks a lot. Okay, ending this session.